So I'm interested in two main aspects here, both what the material innovation means for data storage, how it changes our relationship to knowledge in the past and the future, and what these new challenges or solutions this might create by innovating on the material level. And secondly, I'm really interested in how decisions have been made around what data should persist, what should be allowed to last for 1,000 years.
On the surface, saving data, digital data, looks so simple. After all, they're just a bunch of bits and bytes, aren't they? I mean, how hard can that be? But that preserving data is anything but trivial, whether it's for now, later, or even for centuries, is something I'll explore with my guests for this episode, all experts in the field, including Katie Mackinnon, who you've just heard. Saving data has a very long tradition, if we count, as I think we must, the written word. From the very early stages, people wanted to preserve records and accounts, religious texts, stories, poems, and of course novels and fiction. The materials they used were meant to last, and of course they did. Archaeologists continue to dig up clay tablets with some of the earliest examples of human writings. And in the 1940s and 50s, papyrus rolls were found, the so-called Dead Sea Scrolls, which were stored there nearly 2,000 years earlier and were still found to be in a remarkable and at least partially readable condition. Paper has turned into a very popular and lasting medium as well, of course, to store not just written words, but tables of data, for instance. Now, as in ancient times, archives and libraries are keepers and guardians of this collective output. But within the last 50 years or so, a very different kind of creating and storing data, including the written word, has emerged. I am talking, of course, of computers and the software applications that run on them. With the widespread use of electronic devices and digital storage media, we are witnessing a true explosion of data in electronic form. So much so that modern archives and libraries spend a considerable amount of their effort and time on curating this vast collection of human and machine-generated output for future generations. But how is this done? And what are the challenges in keeping the output of our times safe and accessible for years, perhaps even for centuries to come? What will historians and researchers of the future make of this immense outpouring of digital data? Last year, for a French language episode, I talked to Guillaume Lévrier, who works at the French National Library in Paris and who wrote a program called Pandore that allows users of the library and archive to access content. And I remember that he mentioned all the digital content the BNF, that is the French National Library, tries to store, including content from, for instance, web pages or even social media postings. After meeting Guillaume, I had the pleasure of meeting other experts in the field, including Andrew Jackson from the Digital Preservation Coalition, Nanna Bonde Thylstrup and Katie Mackinnon, both from the University of Copenhagen, Thorsten Ries from the University in Austin, Texas in the US, and Laurisa Sastoque Pabon from the Southampton University in the UK. And together with my guest, I want to take a deeper dive into what it takes to preserve and restore data. I'd like to kick things off with Andrew Jackson. And in our conversation, we touch on a part of digital data we take all for granted, how data are stored in what we call file formats. So here's Andy.
So no, my name's Andy Jackson. So I actually started off life as a physicist. Mm-hmm. So I used to do simulations of physics systems and work with scientists. Although I'm a scientist by background, I ended up working in the British Library. I was trying to get a job just as a software engineer, actually, but I ended up working in this new field, which I hadn't heard about, called digital preservation, where we try and look after digital content for the long term. So I worked there for many years looking after the web archive. One of the things the libraries in the UK do these days is try and preserve digital publications like they've been preserving and conserving books for years. So I used to work on the UK Web Archive there, looking after collecting the UK web output. But for the last couple of years, I've been working at this new place, the Digital Preservation Coalition, and helping other organisations look after digital content.
The Digital Preservation Coalition, what exactly is that? And what is it that you're doing there?
We like to think of it primarily as a community. It's like a member organisation. I mean, it's a charity, so as much of what we do as we can, we make publicly available for everybody. But we're a member organisation and pulls all of those individual organisations together to try and find shared challenges and connect with each other to learn how to preserve digital material. So most of the coalition members, they're many of them are like traditional cultural heritage organisations, libraries, archives, and that kind of thing. And they've all been recognised that digital culture has come along and they need to adapt. And so we kind of provide a forum, a way of connecting and understanding how to do that. There's a number of different strands to that. One of the big ones is learning how to adapt to that. So if you've got binary files to look after, you need to keep the files safe, right? That's a kind of primary thing. And understanding what these primary things are and how to make sure you get the right files and make sure you have the right to preserve them and the right to provide access to them. So all the legal stuff and all that things. Understanding the shape of the problem is a thing we offer training for. So there's free courses that have been funded by the members but are now available for everybody. The main ones are kind of called Novice to Know-How, which are these free online courses which you can take and our members use to train up their own staff so that they're better positioned to look after this stuff. Another important strand to what we do is the advocacy part, and there's kind of two big bits to this. Often we see an organisation, it knows it has to preserve digital records now, or digital material, but it doesn't quite know how, and it tasks a small group or even an individual with solving this problem. And so they need help to advocate within their organisation to communicate what they need to get the resources to do a job. So there's this kind of individuals advocating upwards is one part of the advocacy work we do. But also we try and do some outreach advocacy, some kind of more global stuff. So one of the things I've been involved with is this bit list, this kind of global list of digital preservation that's at risk, kind of modelled after the species red list. That is published, like the giant panda is at risk. And so we have this in social media.
So what's at risk digitally then?
What's at risk? Well, one of the big ones is we always used in the field, because I've been in it a while, we always used to worry about format obsolescence as the primary risk. And it is a big deal. Don't get me wrong, we'll get onto that. But what the biggest ones are the way platforms and capital works. You remember MySpace? Do you remember Bebo? These platforms we depend on in our lives, right? Which all of our lives and our records go into, and then they have control and they can just go. So platform risks and social media are some of the big risks now. But then there's other legal and technical risks. So I recommend people, maybe we can get a link in the show notes maybe about that, because the bit list is a really good advocacy tool reaching outwards, going, this is the shape of the problem. And it's a nice thing for our members as well, because our members build those lists, right? I don't come up with it. It's pooled knowledge across the whole membership, which goes, this is a challenge, a real challenge we're facing, and this is the consequences if it doesn't get. There's that kind of global advocacy. It's a really nice part of what we do as well, I think.
Is the British Library actually a member of the Digital Preservation
Coalition? Yes, British Library was one of the founding members. So going right back to, it's nearly 25 years ago now. It's our 25th anniversary coming up in a couple of years. So the British Library and other, I can't remember who the other founders were, but I do know.
I think it's probably a long list.
It is. But so a lot of the national archives and libraries, initially within the UK, it started off as a UK organisation, but it's now a global organisation. So we're very proud to have the Library of Congress and NARA, the National Records Archive and Records Administration of the US, but also Australasian partners and all over the world. So we're now a kind of global coalition and trying to come together to solve these problems with the restricted resources we have in our field to address them.
So how many resources do you have then? I mean, you're working there now after you left the British Library. You're working there. How many others are there?
How many people? We're 13 now. We're quite large for an organisation in this sector, because we have about 160 members now globally. Yeah. And so there's a lot of work to do on all of those three strands. And so I'm in one team, one of the bigger teams, good practice. We don't talk about best practice because we don't think the field's mature enough that we know what best practice looks like yet. So we're always very cautious about that. We're always like, no, it's what's in your context, what works, and what's good practice for you and institutions like you. So so there's my team, which is building up good practice and doing research on file formats and things like that. And then there's teams for advocacy and training.
Yeah, file formats is what I want to talk about next. Most of us are familiar with file formats, whether it's PDF or Excel or Doc and all the other file formats. How many are there actually?
We realised we hadn't really asked this question. You've said it's like foundational to the task. There's knowing you need the files, collecting them, keeping them safe. None of that matters if you can't access them. If the people, or it doesn't have to be you, but if the people you're preserving them for can't get into them, and the file format is the thing you need to know. It's the connection to the software that makes them open. And so what the kind of linchpin of this within looking inwards within the digital preservation community is this database called Pronom, which the National Archives of the UK run. And that's the one that's considered the kind of high quality, precise. It doesn't just do format like PDF. It knows the difference between PDF 1.4 and PDF 1.7, right? It's very it's very precise and detailed. And so what we usually do, what our members usually do is they check against that. They get a load of files and they check, well, what have we got? And that knows about 1,600 file extensions in that system.
1,600.
Yeah, 1,600 in that. But I knew anecdotally, it's not the only source we need to go to sometimes. There are more formats out there, and there's other information sources we use. So that Library of Congress have their own one, and National Records Administration of the US to have. But also, of course, there's Wikidata, and there's a kind of community wiki called the Just Solve the Problem File Formats Wiki, which also has more. And I started building tools to search across all of these different sources to help people find what they've got. It turned out there were bigger gaps between those sources than I thought. Like some of them are bigger than others, and I thought, well, presumably everything in the small ones is in the big ones, and it wasn't. So I was trying to work out how to analyze this. And at some point I realized I could kind of steal from ecological modeling. So like imagine you're in the rainforest, right? And you want to know how many species you've got. You pin out an area and you count how many species and you get a number. And then you go to a new area and pin out another area and count how many species, but you count how many new ones you get. And you go somewhere else and you count how many new ones you get. And each time in a given habitat, you'll get fewer and fewer new species because you're tending towards knowing how many there is in total, right? If you kept going, you'd know how many there were. So I realized each of these format information sources I could treat like a random sample of the ecosystem, the global ecosystem of file extensions. So I kind of started with Wikidata, and there's like 7,000 in there, and then I went to Pronom, and there's 1,600, and we're pulling all these sources. And it worked. You could see this trend heading towards a stable figure. And it turns out there's about 12,000 file extensions that are worth cataloguing out there. Now, to give that in context, like Pronom, they're like the linchpin of this part of the field. They've been doing this for 20 years, putting in consistent effort every year for 20 years, and they're an eighth of the way there. And so we need to find ways to help them, right? Ways to us all to come together and solve this, because it's a bigger problem than we thought. And it was quite satisfying to finally have a number, but also a little bit intimidating to realize the number indicates we have a long way to go.
If you compare it with ecological data, I mean, it's a little bit different in the sense that between different checks and random checks in different ecological systems, you can be fairly confident that the evolution doesn't work quite so quickly, that one species goes extinct, while another pops up. Whereas file formats actually can go they can get obsolete after a while, and some of them are very short-lived. I would also imagine that there are a number of file formats which is very difficult to ascertain exist, because not only have they gone obsolete, but also at the time they were rather niche and probably maybe just a file format for one company, I would imagine. Yeah, so how do you deal with that?
Well, they're a huge challenge. The biggest case our members hit really, which is like that, is in personal records or in scientist labs, where obviously if a scientist has got funding to look at a particular problem, they'll end up with data formats specific to their problem, and they're the only people that need them, and they're the only people that support them. And there's a limit to what anyone else can do to preserve that in the long term. We can collect the software and collect example files and documentation and make that shareable, and that will help. But those really niche formats, they're a big challenge, and all we can do is try and, if people care about the data enough, encourage them to share open source implementation of the code, right, and share the software and share the documentation of how they use them, and we'll try and keep that. And then at least means there's something to build from.
Actually, there are several elements to the question, one of which is, how do you deal with obsolete formats? Yeah, and you already mentioned that what you need in addition to the file format itself or the file format specification is some kind of software that's able to read it. But also, how do you actually ever get to a number? That's the other aspect. How do you get to a number of file formats when there might be some niche file formats which used either in a company or you mentioned a science lab and for a very specific purpose?
All I can really look at in my analysis is file formats that some third party has thought important enough to catalogue. So absolutely, this is only ever kind of a lower bound. There are at least 12,000 formats is what I'm saying. And in those niches, we're not going to necessarily find out about them unless they choose to share that information and choose to publish it more availably. So then it's more about making sure people in those niches know how to look after them for themselves, like within that area. A lot of good work's been done. in science by the Turing Way. I think you've had them on the podcast in the past,
Yes.
the Turing Institute. And for me, that's kind of that digital preservation challenge in those niches on a short timescale. But also what does help across these niches, and unfortunately has become more common, is that people reuse existing formats and build on them. XML used to be popular. The libraries and archives still love it. If you're using JSON or XML as a basis, then at least you can open up something and start to look at it. And so there's been some good news here in that even the big formats like Doc, Microsoft Word, it used to be a big proprietary .doc blob of stuff, which was very hard to understand. It's still challenging, but now it's a zip file with some XML in it. By leaning on formats and building on formats that are stable and have been used for a lot of different purposes, that's one way that kind of people can make sure stuff maintains accessible, because at least you can take a look at it.
The upshot is that storing the data is not enough. You also need to have the tools to actually interpret them. I mean, it's other than you go into a library where you have a book. Okay, you have to understand the language in which the book is written. But I mean, so at least you can access the book. Whereas with digital data, you cannot really access the binary data unless you have a tool that actually interprets them for you.
Exactly. This is a big challenge for the legal deposit libraries, because they take all this digital content into their collections, but they have to control access to it, because they don't want it being copied out again, because it's the terms of the legislation mean you don't want it kind of leaking out into the open web. It's supposed to be only available on site, because it includes stuff from behind paywalls and ebooks and films and all this kind of thing. So that means if we're going to provide access to that, those institutions, they're not just responsible for giving you the bytes and saying, there you go, there's the file. They have to play back. So exactly as you say, you have to understand the format so you can render the files to the readers. And, it's fine if it's a PDF, because that's easy. But if it's someone's floppy disks from their personal collections, providing access to those becomes a major challenge. So you need to look at ways of, understanding what you've got, maybe migrating the data out of those kind of formats if that's suitable, but you always lose a bit of something. We hear stories from members. It's like some people in their institutions wish we could just print everything out. They know what they're doing then, and they're like, "You're not going to print out the web. You're not going to print out. It's not going to work." But we know we're doing with paper, right? And it's that thing where with the digital stuff, our institutions, they're not that comfortable with that access part. And a lot of fundamentally all digital media is software. From a certain point of view, every PDF file is just a configuration file for a PDF renderer, right? It's a save game for the most boring game in the world. And so getting that understanding and what that means for accessing, and whether, it means emulating old platforms in the future, or whether it means getting data out of them, it's a big challenge that we're going to face as time goes on.
Could you perhaps give us a concrete example of one of the formats that's gone obsolete that you looked into?
One kind of big one, which I think people will be familiar with, particularly if they're of a certain vintage, will be Flash. If you remember the early days of the web. Do you remember when the web used to be a lot more complicated in some ways? There was Flash, and there were Java applets, and then there was Real Media Player, and there was virtual reality markup language and its players. So there was a lot more complicated little players and applets and things for accessing things like animation and video and virtual worlds and all that kind of stuff. Those used to be quite common, particularly Flash. It was everywhere and it was extremely popular. But now it's gone, it's obsolete, and it's quite hard. If you try and install a Flash player on your PC, it probably won't let you because it's not secure anymore.
Right now, that is in the year 2026, there may not be that many people around to remember Flash and other file formats that have not survived the course of time. But obsolescence is not the only challenge you face when you try to preserve data. And in fact, my next guest, Nanna Bonde Thylstrup, argues that data loss goes hand in hand with saving data, which is exactly what you presented in autumn 2025 at the University College London at an event organised by the UK National Archive, where I've met her. And a while later, Nanna and I met up again to talk about this in more detail.
I'm Nanna Bonde Thylstrup. I'm an associate professor working at the intersection of critical data studies, STS, and digital culture, and I currently lead an ERC-funded research project called Data Loss.
We met in London during, I think it was the annual Digital Data Festival or Day, organised by the National Archive in the UK. And you gave an excellent presentation there with regards to data loss. And I think, as far as I remember, your argument was that data loss is inherent when we start saving data. And I wonder if you could explore that for me a little bit more.
First of all, thank you so much for your kind words. Overall, in the project, my team and I study what happens when data disappears, when it's destroyed, and when it becomes unusable. And we approach these phenomena and cases and incidents not as accidents or anomalies, but rather as structural features of digital societies. So we look at public sector infrastructures, we look at platforms like GitHub, we look at archives, and we look at AI systems, asking how loss is produced through everyday technical and institutional practice. So a lot of my recent work focuses on that simple claim that data is itself one of the primary ways data gets lost.
Could you give us a concrete example of how that might happen, actually? When people say saving data, they think they're doing the right thing.
Right.
But actually, they're also losing data at the same time.
And important for me to say that losing data isn't always the wrong thing. It's not because people are doing things wrong. What we look at is simply the empirical phenomena, and then we try to theorize around that when we talk about saving data, we usually imagine preservation as neutral, to keep something safe or unchanged or intact. But empirically, we can see that that's not how digital systems work. So in digital infrastructures, preservation always also involves transformation. That is, formats are converted, systems are extracted from their environments, functionality is stripped away, and metadata, for instance, can be standardized and access is constrained. So each of these steps are examples of steps that solve one issue or challenge or problem and introduces another. So when I say that data loss is inherent in saving data, I mean that loss is not what happens when preservation fails, but rather that preservation enacts loss as well, systematically and routinely. We can talk about why that is more concrete, but I do have some examples, for instance, from archives, which are historically and institutionally some of the safeguards of digital memory. These stem from my fieldwork in the Danish National Archives, which I found a really fascinating place to look at instances of data loss in institutions that are legally mandated to keep digital data safe or preserved for eternity, ideally. There's no endpoint as to when they should stop saving data. And one example is spreadsheets, which they are themselves wondering how to preserve. So we know spreadsheets as very common, mundane formats, also in public administration, of course. They're used for budgets and planning documents, calculations. But the Danish National Archives, as I think are more endemic to archives in general, is that they don't necessarily preserve Excel files as Excel files. Instead, they convert spreadsheets into formats like TIFF images or XML tables.
Right.
And that means that formulas disappear. So everything that enabled their functionality, that would disappear into a flat image. That means that interactivity disappears, and it means that the computational logics, so to speak, underlying Excel sheets also disappear. To me, that means that what gets preserved is the appearance of the spreadsheet, what it looks like, but not necessarily what made it meaningful as a working object. And this was alerted to me by one archivist who told me very bluntly that when you convert data, you can never do it without losing information. Here, saving the data produces a loss of functionality and concept, but also epistemic value.
This is quite interesting because spreadsheets, we think of them as, almost like standard formats nowadays. So is there a particular reason why the archive decides not to store them as spreadsheets and rather as TIFFs, as images, as you say?
Yeah, so they have opted for TIFFs because, as one other archivist told me, that TIFF is a dead format. So for me, that's also really interesting that they're battling on several fronts in terms of preservation. One is material decay, but another much more insidious one is planned obsolescence at tech companies. And they say that there's simply too much updating happening around these commercial formats, where TIFF is deemed to them as a much more durable solution for long-term preservation simply because it's not updated much.
It's an interesting aspect, actually. So you deliberately choose a dead format, so to speak. Because, the other ones are changing so often, so frequently, that it's difficult or too hard to keep them up to date, basically.
Exactly.
Are there any other examples, apart from spreadsheets?
Yeah, another example that they offered to me is 3D models. Government agencies increasingly work with 3D models, which are spatial and layered, but also often navigable objects. And they're used for urban planning, for security purposes. So they're used for a wide variety of purposes. And often they also are quite crucial to political decisions in relation to urban planning, for instance. But the archives, similar to spreadsheets, also only accept these as flat representations. And that means the three-dimensional knowledge becomes two-dimensional documentation. So one of the archivists asked a crucial question to me of a more hypothetical manner, thinking about how historians would interpret the preservation of these documents. They said, well, they worked with spatial formats, they being the politicians or decision makers, and then they flatten them for us. So how authentic is it then? And that's, of course, the question. How authentic is this data for the future historian? And I would say that that's not only a technical issue, but also, even as researchers, we don't mind necessarily talking long here, but I would say that it's also quite an ontological one, in that the archived object is no longer the same kind of thing as the original.
Yeah, that's an interesting aspect. And I think that's my last point that I would like to touch on. I mean, you mentioned that historians would like to make sense of the data that were accumulated sometime in the past, but you can't really accumulate all the data. You have to make selections. And therefore, isn't selection also some kind of loss, in the sense that, you know, when a historian looks at it in maybe 100 years' time, they think, why didn't they record that?
Oh, absolutely. And I think that that's why I really appreciate working with archivists, because they're crucially aware of the political nature of their selection processes. And of course, that's the selection process, and the appraisal process is what creates a red thread and some consistency. And so you could say that it's what divides or distinguishes just noise to a collection that you can read. So archivists are also very aware of material constraints, and that's why they've always worked with these constraints, right? And first it was just archiving royal letters or the most powerful. Later it became more statistical representation purposes. So in Denmark, they would preserve 3% of the Danish population. But of course, there was also that question of how much paper could they have in their cold storage. And the Danish National Archives are very big. We also have a very big public sector, so they produce a lot of data. And now, of course, the Danish state is also one of those states that have adopted a digital administration very early on. So they've had to contend with selection processes around the digital. And they say that it changes their criteria a little bit, because on the one hand, you can, of course, save much more digital data. But on the other hand, they also now face new questions, new paradoxes. Should they collect biometric data, which is much closer to people? Should they collect a much broader representation of data, for instance, also civic nature, simply because it's possible? So they're constantly weighing off privacy and political issues vis-a-vis their preservation capabilities, and add to that also a rising concern with environmental impacts of data storage and processing. That makes for a really complicated but also really interesting conversation about what do we save, why, for how long, and for whom.
When we think of saving our data, we may think of hard drives, magnetic tapes, or other media, which is okay for our daily use. But as you heard from Nanna, archives and libraries think in longer terms. And for that, our daily backup and storage solutions are not good enough, or for the most part aren't good enough. And this brings me to Katie Mackinnon, who, like Nanna Bonde Thylstrup, works at the University of Copenhagen. Katie is working on 2 exciting projects concerning long-term data storage. And this may surprise you. Well, it certainly did surprise me. Perhaps you've heard of the Svalbard archipelago off the Norwegian coast in the Arctic Circle. Well, you may have, because one of its islands, the island of Spitsbergen, is the home to the so-called Doomsday Vault, a storage facility to preserve plant seeds. Well, the very same place isn't just used for saving and storing plant seeds, but also for preserving data, which is where the 2 projects Katie is working on come in. So here she is.
My name is Katie Mackinnon. I am a postdoctoral researcher on the Data Loss Project at the University of Copenhagen. I am originally from Canada, where I did my PhD at the University of Toronto.
Oh, right. Okay. Since when are you in Copenhagen then?
I've been in Copenhagen the past 2 years working on this project.
Right. And the project is what we're talking about because it involves the Arctic vault in Svalbard. Is it Svalbard or Svalbard?
I think it's Svalbard, but my Norwegian is not.
My Norwegian is non-existent. So What are these projects?
So for the Data Loss Project, I'm actually looking at a number of what I'm calling deep time data projects that are involved with innovating on storage. So there's a bunch of different companies, organizations, libraries, governments that are all experimenting with different methods of storing data for hundreds to thousands of years without the need for very much human intervention. And the goal of the projects is to create systems that are sustainable, so a light energy footprint, low cost of maintenance, little waste produced. And because many argue that there's a crisis of storage in the new AI era, where hard drives and tape have reached the end of innovation, and we need to create new systems to store these very high-powered computing processes. So in Svalbard, I'm looking at 2 different projects, both using the same product. There's a new archival medium that was developed for long-term data storage called Pickle, PIQL.
Oh, right. Okay.
And the 2 projects that are both stored in Norway are the Arctic World Archive. They have partnerships with different cultural institutions that donate data for safekeeping. They'll have things like 3D renderings, archival images, videos, maps, digital maps, any type of digital sort of artifact that
audio as well, I guess.
Yeah, exactly. And then the other project that I'm looking at is GitHub's Code Vault. This one I'm particularly interested in, and I have a paper about it, and I'd be happy to tell you more about what's happening with the GitHub archive.
What's your particular interest in GitHub?
Let me say first that when I talk to other GitHub users, and if there's been many so far at this point, because I've been researching this for the past year and a half, people get badges if they are included in this archive project. And when I look for their different repository or their username in the reference list, I can't find them. So there's sort of an interesting question around what actually is stored in this archive. And I think it's a little unfortunate that there wasn't more sort of conversation or participation from GitHub users around whether or not they wanted their repositories. Some people say, I'm not sure that needs to be saved for 1,000 years. So it's sort of an interesting question.
Goodness me, yeah. That's a reason for another science fiction movie. Waking up after 1,000 years, some piece of software. So what is it that you're actually looking at?
Yeah.
Are you looking at the specific storage solutions in terms of data loss? I'm trying to connect sort of the data loss aspect of it because I talked to Nanna, your colleague, the data preservation, which is clearly what this is. So where's the link?
So I guess let me introduce the project a little bit first. So the GitHub Code Vault was created in 2020. And this was when 17,000 repositories were algorithmically selected to be part of the greatest hits of GitHub. The CEO at the time, Nat Friedman, he said in some press releases that they were designing something that would protect the world's software from apocalypse. They took these repositories and they printed them on the long-term archival medium, developed to store data for this very, very long time. And it's essentially microfilm. This is an interesting research area for the Data Loss Project because obviously the goal of archival projects is to preserve and prevent loss.
Yes.
But what we find across a lot of our research sites, not just these ones, is that the way in which data loss happens is baked into digital infrastructures. And so in order to save something for 100 years or 1,000 years, it has to be transformed from its original format and removed from its original context.
Exactly. And there's some loss associated with that, as Nanna explains.
Absolutely. Yeah. So I'm interested in 2 main aspects here, both what the material innovation means for data storage, how it changes our relationship to knowledge in the past and the future, and what these new challenges or solutions this might create by innovating on the material level. And secondly, I'm really interested in how decisions have been made around what data should persist, what should be allowed to last for 1,000 years. And in that sort of decision process, what data isn't included and what sort of gets left behind. Because as I said, they only saved 17,000 repositories, which means that, there's many more than that on GitHub.
Hundreds of millions, in fact. Yeah.
Exactly. So all of that has been chosen to not be preserved. And I think that's sort of a really interesting process that they don't really discuss or describe. And it's because the decision-making took place with an algorithm. I find that sort of interesting as well.
Yeah, indeed. And you mentioned microfilm. Did I get this right?
Yes.
I do remember microfilm from libraries in 1980s and 1970s, where you could read news articles, from old papers. But how do you do that with software?
Yeah, that is a really interesting question. I talk to researchers who work on these types of projects. And I should say that it's not just microfilm. I've talked to sort of other groups who are working with glass or ceramic, hair. Like there's a lot of different sort of innovations happening in this space around what material can hold data.
Yeah.
But obviously microfilm has a pretty solid history of being widely used in the film industry, for example. So I think that's the history of this particular product, is it comes out of that tradition. And they've made some sort of modifications to it to last for that long. But essentially what happens is they take the code off the platform. It goes into their own sort of like online repository, and then that gets referenced through a code that's then printed onto the microfilm. So in 1,000 years, you'll still need to access the underlying database where all this stuff is actually stored.
That's quite interesting in itself, because you need to have the means to do so. And in 1,000 years, that knowledge may be lost. So people, archaeologists in 1,000 years, whoever they are, and they might listen to this one too, So they look at this and think, what the hell is this? And how do I do that?
Yeah, they're thinking about these questions. So for the GitHub project, they have, for example, published alongside the archive this tree where they have translated the languages across at least 8 different languages so that it could be read by different people. So it's not just English. They also argue that it is machine readable. So if in 1,000 years, language is transformed so much so that we only have code and we sort of lose different languages, then it can still be read. And they're also sort of experimenting with the reader technology. So, for example, you can use a magnifying glass and a camera rather than their specific reader technology. So I think these types of things are being thought about, but it is sort of hard to predict where we'll be.
Indeed.
Yeah. And the other thing I find interesting about this too is that for a platform like GitHub, the moment you take the code out of the repository, it's dead. Right? Because this archive separates the code from the coders for eternity. Not that this is the only copy, but as you know, it requires so much updating and maintenance to keep software working. So the moment you pull it out of a system, it's inoperable. And it sort of makes an interesting type of artifact where we won't necessarily be able to use this stuff, but we can still have the trace of it. So it's not necessarily that we're preserving software, but that we're preserving the trace of a particular platform that hosted software.
Andy, Nanna and Katie have been talking about data being preserved for future use. But what about recovering material from the data we already have? After all, people have been using computers to write, analyze data, and store digital material for several decades now. If you remember what Andy said earlier, we have a plethora of different file formats and bit streams of data. Some of the formats no longer exist, and on top of that, the storage media themselves may only be partially accessible. That's a problem that Thorsten Ries faces when analyzing writing techniques from writers and authors. And to solve this, Thorsten and his colleagues are using techniques from a field that may surprise you.
My name is Thorsten Ries. I'm an assistant professor at the Department of Germanic Studies at the University of Texas at Austin, and I happen to be also specialized in what we call digital humanities, and more specifically, I'm using digital forensic tools for born digital preservation. So I'm by and large interested in what we call born digital archives, that are archives that are digital but have also originated as digital archives, meaning they have not been digitized from analog sources.
Oh, right, okay, but that's quite a specific subsection, because we do have, like for instance in libraries, when you digitize printed books, printed material that would be non-born digital, so to speak.
Yeah, or analog-born
Analog-born
archives.
But I think you also specialize in particular in literature. So what I could see from the website, that you analyze the working or the writing process of authors. Did I get that right?
No, that's spot on. So I'm going to tell you a bit the anecdote how I got there after saying what that is. One of my main research avenues is analyzing literary authors and philosophers, for instance, hard drives to recover stages of their writing process, draft material that they may not have been even aware of because it is still on their computers that have been archived and is still recoverable. How I got there is actually me being originally an analog archive guy. So I've been spending years to be able to read German expressionist authors' handwriting, Gottfried Benn, in order to trace his writing process. And while I was doing that, while I was staring at his handwriting for years and hours on end, I was at some point wondering, okay, like I have this computational knack, and at the same time, I wonder, do my colleagues actually know that not everything that an author writes on their laptop is entirely gone apart from the last saved version, if you know how to preserve that hard drive? And that's where my start into the topic was, and that was about 2009, just briefly after the publication of Matthew Kirschenbaum's Mechanisms book of 2008, which started the topic. I haven't read it at the time. It was actually quite difficult to get the book in Germany. And I started then with my first talk in 2010, scoping out that topic for German literature.
Well, that's quite a journey. And you mentioned forensic techniques. That seems to be a step further still. Because, I mean, you're saying you're trying to discover the working or the writing processes from authors, because the published version is ultimately only the final version. There may be another version coming in future when they make some changes to the published, and then this is the second edition or something. But let's not go into that. But before then, there is the manuscripts that actually see editing and changes, etc. So where do forensic techniques come in, and how did you get into that space?
For the non-literary scholar, this may sound a little far-fetched, but actually we have been doing this for a good 200 years already, using forensic analog techniques to analyze manuscripts. There has been chemical analysis of author manuscripts. Using forensic techniques to recover writing processes and understand authors better is actually a rather old technique and technology. And just to clarify, when we say forensic analysis, that mainly refers to the techniques and technologies that we borrow from forensic practitioners, because we are in philology also work, and in archives we're working with evidence, but our goal is obviously not the same as a forensic practitioner's. A forensic practitioner looks for evidence of criminal activity on the system, and oftentimes they only look for one instance of evidence that makes their case. Whereas our goal obviously is not incriminating the subject. Actually, we are, unlike the forensic practitioners, we ask for permission before we access anything, even in the archive. And our goal is not sort of like to find this one incriminating piece of evidence. We are looking for the traces of the whole writing process, for instance. We are interested in the hard drive as a cultural object.
You mentioned analog forensics techniques. And in the olden days, if I may say so, well, they're not quite so olden because we still have printed media, of course. But you mentioned paper and chemicals. And then, of course, the handwriting analysis itself. I mean, you looked at Gottfried Benn, for instance, and that's analog, and some of it can be digitized. But I think digital data probably require different forensic techniques. Could you give us an overview what kind of techniques these are? What it is that you borrowed, say, from the criminologists that actually look for criminal evidence, which you're not, but what kind of techniques can you use?
This is a very welcome question to limit a little bit the scope of what digital forensic mean in this particular context. And this is also a note and a shout out to the digital forensic community that is in the DFAR and the digital forensics and incident response team space. This is mostly not what we do when we talk about Born Digital Archives. We may use some of these tools to access a hard drive that is locked with BitLocker, or such tools may come into scope if we find malware on an archived storage medium. But mostly we're talking about historical digital forensics and data recovery. So the first thing that we do is we use forensic tools for data preservation and storage medium preservation, bitstream preserving copies that copy everything that was on a person's hard drive, including the deleted or the traces of deleted data on this drive. And the next thing is general forensic analysis of obviously what was on this drive, what are the traces of activity by this author, categorizing this data. And what forensic practitioners normally don't do is obviously we're looking at how this data can still be accessed in 20 years, in 30 years, in 50 years, when most of the applications that use these files are no longer in use, are no longer maintained, and are considered as obsolete.
So we talk about hard drive, and hard drive comes in very different shapes and forms, like, for instance, floppy disks, the hard disks in a computer. But we also have different storage media, such as solid state devices, for instance, etc., and magnetic tapes. They do exist as well. Are you particularly interested in one type of hard drive in that broad sense, or do you actually look at various different materials and various different sources?
I do, in fact, look at almost the whole spectrum of traces of author activity, and hard drives is sort of like indeed the umbrella term. Floppy disks can be part of that. Extracted data streams of a Google Docs account can be such an asset. It is interesting that this creates a disciplinary field that goes beyond what we regard as the usual digital forensics angle. Because historical digital forensics requires angles and skills and access vectors that are often not known to or accessible to general forensic practitioners, which are obviously focused on present-day technology. So what can happen in this practice is we come across an archive, and I can say that we have a number of archives here at the Harry Ransom Center in Austin, where the drives have been forensically secured and are in a file system format, that does not exist anymore, and that has been created before digital forensics was created. So we don't actually have tools at our disposal normally, because nobody thought at the time anyone would commit crimes with these machines.
Yeah, those were the innocent days.
With very old Apple Macintosh machines with the very old HFS file system. I had a number of cases with that. So that's fun. And then we start programming our own tools. And it is just anecdotally, I can say that it was astounding to me when I gave my first talk in front of a digital forensics community, that after the talk, people came to me and said, we had no idea about this. And I was shocked. I thought those people, those specialists would take me apart, honestly speaking. But in fact, this historical angle is actually something they are not training on. And oftentimes this is really knowledge that is being forgotten, which opens a whole archival and information science discipline and disciplinary knowledge that is very specific.
So you mentioned the history of digital forensic science or digital forensics activity or techniques. How old is it actually? How long does it date back?
This is where I look something up. 1 second.
Of course.
So digital forensics actually goes back to the late 80s and early 90s.
Right.
And the first tools that were then open sourced were made available in the early 2000s. The earliest tool that I know of is called Foremost. It's a still used data recovery tool for deleted data that was published in 2001, as far as I can see. But before, digital forensic activity was often about catching freakers who used their landlines illegally, meaning for cheap, or circumventing the payment mechanisms to use the internet, or have sort of like some kind of non-legitimate account or access to a mainframe, sort of like spotting this type of irregular activity. Oftentimes, in its very beginnings, relatively harmless compared to what we're looking at today. And this goes back to the foundations of the earliest hacker communities, such as the Chaos Computer Club in Germany, I think founded in 1986 or something. And a few months later, the second oldest hacker community, the Cult of the Dead Cow, which was founded here in Lubbock, Texas.
We're coming to the end now of this tour of preserving data, but before I finish, I'd like to turn to Laurisa Sastoque Pabon from the Southampton University. Southampton Uni is offering training courses and consultancy services to help people prepare better for saving their data long term.
So I'm Laurisa. Thank you for having me. I am a digital preservation training officer at the University of Southampton. We work on an enterprise unit called Digital Preservation Southampton, where we offer training, consultancy solutions, data recovery for institutions and organizations and professionals in the cultural heritage sector and beyond who would like to learn more about how to implement digital skills in their workflows. Externally, I am also a PhD student at the University of Cambridge, working on diasporic communities and Latin American diasporic communities and their production of space. And yeah, I think that's about it from me.
Well, that's quite a lot. How do you train people? Since you're now involved in training people to preserve their data, how do you train that?
Well, we launched actually at the start of this year, at the start of 2025. It's been kind of evolving, right? Because we've kind of been figuring out what works more and more. But right now, what we're aiming for is kind of a recurring set of workshops. So every, let's say, quarter or so, we're aiming to have like monthly workshops on different topics that are of relevance. So far we've done 3 different workshops. One of them has been on metadata wrangling, so learning how to transform metadata collections using different kinds of software, learning strategies for that. Another one has been about digging into the foundations of digital preservation. So all those core skills that you want to know to sort of get started doing some of these digital preservation activities at your organization. So things like identifying file formats and a lot of the decision-making processes of, is this file format going to be suitable for the long term? What action should it take in a given case? And we also recently had a new one that was called Working with Legacy Media. So that one was about creating forensic images of media such as CDs, floppy disks, hard drives. So people in institutions that have a lot of holdings of these could stabilize that data, since these are carriers that are sometimes at risk of degradation, of obsolescence. We kind of try to understand who's coming in, who's in the room, the attendees, their backgrounds, and tailor the materials a little bit to sort of fit those needs. And we also try to take an approach that's very hands-on, so making sure that everyone comes out with at least a bit of familiarity with these tools, because a lot of times you learn things very conceptually, but to give people at least a bit of that encounter with what these interfaces look like.
So who is your audience then? Is it for academics, or is it just anybody who's interested in preserving data?
It's usually really anyone who's responsible for digital assets at an organization, or anyone, who's curious about it. So we get mostly people from the GLAM sector, so galleries, libraries, archives, and museums. A lot of people who hold job roles such as digital asset manager, digital archivist, assistant archivist, right? We got a lot of people coming from institutions that you wouldn't think of as cultural heritage, like food and drink industry, for instance, who also hold archives, because they've been around for a while and they need someone to be responsible for them. We also get a lot of people from higher education institutions who work at the institutional library, who are responsible, for instance, for data management plans. So a lot of people who are data stewards, for instance. And we also get people not only from the UK, but from all over. We find people from Singapore, Hong Kong. It's quite an international group, and we're hoping to keep expanding to more international attendees.
From your experience, and I understand and appreciate that you started operations earlier this year. So, it's not a long time, but it seems like a lot of activity has already happened. So from that rather short perspective, what do you think the main pain points are that people have when they come to your workshops?
In terms of pain points, it's hard to say because people are coming from very different backgrounds. So we get people who, have never worked with any kind of software or coding. Of course, we've all probably worked with software, but who maybe have a little less confidence in approaching tools that maybe sometimes are not as, for instance, like a command line tool. Sometimes they're less user-friendly. At the same time, we get people who are very experienced and who want to learn more about how to apply these concepts to their specific issues that they're facing at their organization. So what we're trying to do is kind of to, of course, be clear about what the content of a workshop aims for, but also try to create something of value to this very diverse array of people who are coming to our workshop. So, for instance, offering both foundational and more advanced sort of versions of exercises is an approach that we take to address this, as well as, for instance, offering like challenges, bones to pick, as you, if you will. A lot of times getting through that initial sense of, I'm looking at a new software, I've never used this before, what do I even do? Getting through that initial sort of shock is often the main thing that happens in a workshop.
So what do you think are the fundamental skills that people should learn when it comes to data preservation?
Learn, first of all, how to identify file formats. There's a good amount of software out there to help you do that. And it's also something that we, to an extent, have done as regular users of computers. We're always trying to understand, is this a Word document? Is this a PDF? What program should I use to open this? Taking that experience and learning how to use tools such as Droid or Siegfried that are out there that can translate this into an archival setting where you have to do this in more detail and with more scrutiny and for larger sets of data. That's one thing. From a technical standpoint, there's things that would be helpful, like learning how to work with the command line a little bit is always helpful to browse through different types of files, and learning how to work with data sets, metadata, how to apply one transformation across several fields. Those are all things that are helpful. I think also from a conceptual standpoint there's a lot of generalized guidance out there, and learning how to interpret that and adapt that to your specific setting, where sometimes you have to prioritize certain objects over others because your organization or your team may not have the capacity to address all of the intricacies that arise when dealing with different types of data and formats. I guess a lot of what we focus on is that decision making and giving people the skills and the confidence and the tools to be able to make informed decisions on the data that they're responsible for.
So when it comes to metadata, you can write metadata in various different formats. Are there particular standards that people should be looking out for when it comes to archiving data? Probably depends on the field, doesn't it?
Yeah, I think so. There's, again, like you said, metadata can look many different ways. Sometimes it's something as simple as a little note written or a post-it note put on top of a CD or something. It can look many different ways. We're looking for, I guess, in a more fair data environment where you want data that's findable, accessible, interoperable, and reproducible. Data that has consistent fields, that follows a consistent format so that you can then look through it, so that users also, once they're browsing through a repository, can search for specific things and get something out of it. In terms of standards, there's tons out there, and it does depend on the field. For instance, one that's very specific to digital preservation is Primus. Primus gives us that backbone, that structure of understanding not only descriptive metadata, things like what an object's author is or an object's description is, but also digital information. So what format is it in? What actions have been performed to keep its digital integrity? So, have I converted it? Have I encountered an error? Of course, the standard can look many different ways. I think a lot of standards out there, for instance, the Open Archival Information System, or AIS, emphasize not having necessarily one specific implementation, but kind of giving people and organizations a structure they can then adapt and kind of make it look like whatever makes sense within their ecosystem.
Finally, you mentioned legacy data and CDs, and there are all sorts of different legacy data. How relevant is that to the people that come to the workshop? Is that happening a lot, that they're saying, well, I have got old floppy disks, for instance, that I want to save the data from?
It does come up a lot, actually. We get lots of people, even at workshops that are not necessarily aimed at legacy media. It's a thing that always comes up. A lot of people having CDs, DVDs, those come up a lot. Floppy disks. What else comes up? VHS comes up a lot, although that's a slightly different ballpark.
It is, yeah.
Yeah, like analog things such as also microfilms, microfiche.
Well, it's been a rather long episode, and I still feel we've only scratched the surface of this subject. There's one topic in particular that I want to cover, and that is how storage media themselves can degrade and the kind of forensic techniques that can be used to restore them again. But this has to wait for a later episode in this season, when you will hear from 3 experts working in the field who will talk to us about why floppy disks still matter and how bits rot on your DVDs and CDs. So watch this space. Next week will be time, again, for a German language episode, and for this I went to Hamburg to meet with 3 scientists and software engineers of the German Climate Science Center to talk about a climate modeling tool that has made some waves in recent times, ICON. Note this will be a German language episode, so if you are a German speaker or want to brush up your language skills, I hope you'll tune in then. Thanks for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.